This is probably a version of Ethernet that you haven't seen before. Unlike most of the versions that I've gone over so far, this is actually very different. For one thing, this is the most money I've spent on any of these videos in terms of buying hardware. These two pieces together cost me about $300. For another thing, this is new equipment. Unlike everything else I've demonstrated, with the exception of the 10Base-T1L, this is new. And this is 10Base-T1S. The reason you probably haven't seen this before, particularly if you're either a network engineer or a home network person, is that this version of Ethernet was intended for use in vehicles, not in enterprises or in home networks. So these are development boards. They're made by a company called Microchip. I really like Microchip. They put out a ton of very useful information about 10Base-T1S. And 10Base-T1S, apart from being part of what has been labeled the automotive Ethernet suite, is also one of the single pair Ethernet standards, or SPE. So in this case, this would plug into a computer with its USB port. And then at the other end are two places where you put wires for a single twisted pair. If you'll recall, 10Base-T is based on two pairs, and there are other versions that rely on a different number of conductors. But this one is two pairs. And the other thing that makes this fairly unique among modern Ethernet standards is that it supports multi-drop. So you could actually have several devices on one electrical bus, one wire, all hanging off that same wire. I haven't experimented with multi-drop yet, simply because I don't want to spend more money buying more of these because they're not cheap. So, so if you look at the end here, this is where the wires go in, and there's some screw down things on top that will tighten up the wires. And then these jumpers here, which I'm not going to take off. These jumpers activate they bridge a resistor, and the resistor, at least as far as I understand it, acts as a terminator. So you would only have this on the end units. So if you have stuff in the middle, again, my understanding, I haven't done the multi-drop stuff yet, you would have to take it off. So let's take out of the box this one. This is how it comes from the company. And I'm gonna take a single piece of twisted pair and connect it between these. So I happen to have, ta-da, a piece of twisted pair, and I'm gonna plug it in here. After I straighten out the wires a little bit, I'm gonna plug them in the end. So I'm gonna put green in the left. Tighten this up. And white on the, I guess it's right or left, my left. All right, so hopefully you can see in here, I actually got it in there. I did have to cut it, not cut the wire, but cut the video so that it was a little clearer. So I inserted it in there and then just tied it down with the screws. So let me do the other end now. So we'll see the other end. So let me open up a gap up top so I can see it a little bit. So again, unlike what you might be used to or what might be intuitive when you're doing these, it's actually same color wire to same, so it's one wire. So if I put the white one on the top, there we go. So now we have the two set up in the same way. When I first tried this, because I'm try things first and then read directions later. I tried it with white on one side going to the other side, and that did not work. So, all right, let's go try it on a computer. Okay. All right, so here we are. We've got our lab set up, and I've got the two cards plugged into two different computers. So I've got one plugged into USB on this old Dell, and the other one plugged on this newer Dell. So let's zoom out and we'll kind of just go over our setup. So I've already pre-configured both of the computers with IP addresses on those cards. So if you look at this one, which is probably easier to see, interface 4 is set up. And here's the name that presents the operating system. It's kind of funky. It's like a combination of ENX and the MAC address. And I've already configured this with the IP address of 10.10.1.11 and with a 24-bit subnet mask. And over on this side, I have it set up on interface 3, and this one is 10.10.1.12, also with a 24-bit subnet mask. So I'm going to ping, actually let me go to the big one over here. I'm going to ping the other end just to show you that it works. 12, so sorry. So I'm getting a good ping. It's taking a little less than a millisecond. It's pretty reasonable. And I'm going to start that ping up again, so it's a constant ping on Linux. And then I'm going to remove the card from this computer, and you should see the ping stop. So the ping stops, and this is just to convince me and you that it is actually going through that interface. So I'm going to put that back in. Hopefully it'll come back on without me reconfiguring any of the software. And there it goes. All right, so that's good. So let's do this now. I'm going to start up an iPerf server on this computer. If you can zoom in on the screen over here, camera person. I'm going to say iPerf-S, iPerf3-S. So iPerf is now running on here. I'm going to go over to this side, which is the client, and tell it to hit that server. And I'm going to start with UDP. And I'm going to set the bandwidth to 10 megabits a second. And the IP address of the server is 10.10.1.12. All right, so we're going to watch iPerf run. And we're getting a solid 10, upper 9 megabits per second, which is exactly what I was expecting. And if you go over on this side, you see I'm not getting too much loss, a little bit of loss. So this is actually the most loss I've seen. So 4 packets out of 824 on there, 2 out of 824 on there, 3 out of 823 on there. So so not perfect, but certainly very, very respectable. Working in a way that was never really intended to work. And I'm still experimenting with it. So we'll see where it goes from here. But thanks for watching. And if you enjoyed, looking at obscure Ethernet versions, please subscribe to the channel, and I'll try to bring you more of it. Thank you.